gate function. Okay, some useful functions we discussed. We will continue our discussion on Fourier transform. Let's take it from here. Now see if we have a problem like this, that is find the Fourier transform of a signal. We have example. Find the Fourier transform of an impulse function. Impulse function. Fourier transform of an impulse function. What is impulse function? Impulse function is a signal x of t which is equal to delta t. So delta t is my impulse function. So we have to find the Fourier transform of this. Now see, we know Fourier transform of any signal is represented by like this: Fourier transform of x of t, okay, which is equal to x of j omega, is equal to x of j omega. And what is x of j omega equal to? It is equal to integral of minus infinity to plus infinity x of t e raised to power minus j omega t dt. Okay. Now x of t here in our question, x of t is equal to delta t. Okay, so our Fourier transform equation will be integral minus infinity to plus infinity. Instead of x of t, we will have delta t. Then you have e raised to power j omega t dt. Okay. All right. Now delta t, we know delta t is nothing but it is equal to 1. Delta t is equal to 1. We can use a shifting property. Shifting property. We can use shifting property. We know that we have already seen if we have during convolution, in convolution discussion, we have seen that if we have an integral like this, minus infinity to plus infinity, then we are multiplying it by delta t dt, it is equal to x of 0. Okay, because delta t is existent at t equal to 0. Normally जो impulse function होती है, it is present at t equal to 0. तो हमने ये इंटीग्रल वहाँ किया था डिस्कस. In fact, we also saw this equation there. If we have an integral like this, minus infinity to plus infinity x of t into delta of t minus t naught dt. So it is a shifted impulse. We said that it will give us x of t naught, that is at t equal to t naught, because the impulse is present there. Okay, I said that it is also used for sampling. So this is basically a shifting property of this. Okay, shifting property of impulse function. This is known as shifting property of impulse function. Shifting property of impulse function. So what we will have now, by this logic, we can write down this equation. Equation 1, we can write down x of j omega will be equal to, now instead of x of t, we have here e raised power minus j omega t. Okay, so it will be e raised power minus j omega t, but at t equal to 0. At t equal to 0. Why? Because delta t, we assume it exists at t equal to 0. Okay, like we have mentioned here, at t equal to 0. So we are assuming that delta t is existing at t equal to 0. So our delta t would be like this. Our delta t would be like this. So this is t, this is 0, this is x of t equal to delta t. We are assuming that it is existent at t equal to 0. Okay, at t equal to 0. So we are assuming that it is existing at t equal to 0. Now see, that is why I said x of j omega will be equal to e minus j omega t at t equal to 0.
सर आवाज नहीं आ रही है.
किसी को नहीं आ रही है? हाँ, everybody is taking same message?
सर बहुत कम आ रही है आवाज, दूर से आ रही है.
दूर से आ रही है हर
सर
किसी
आप
बच्चे
ठीक है,
को?
आप ठीक है सर, आप ठीक है.
मुझे ये तो मैं तो बहुत ऊंची आवाज में बोल रहा हूँ. आई एम शाउटिंग. My neighbors, might be looking from the window. Anyway, so that is why I said x of j omega will be equal to e raised power minus j omega t at t equal to 0. Okay. So once you substitute t equal to 0, it will be equal to e raised power 0. Okay. It will be e raised power 0 because entire power will be 0. So that will be equal to 1. So we have to then write down, we should write it that x of j omega, that is Fourier transform of delta t, it is equal to 1. Okay. Fourier transform of delta t is equal to 1. This can be written in this form also. If we take the Fourier transform of delta t, it will be equal to 1. It will be equal to 1. So that is the result. So we had a signal x of t, which was the impulse. If we try to draw its Fourier transform will look like something this. It will look like this thing. This is 0 here, okay? This is omega. And this is x of j omega, which is equal to 1. And if we'll plot it, it will be like this. So you have an amplitude equal to 1. So this one is the Fourier transform plot, and this is its time domain plot. This is the delta of t, because we are trying to find Fourier transform of an impulse function, So Fourier transform of an impulse function is always equal to 1. Fourier transform. So you should remember, hence the Fourier transform of a unit impulse function is unity. I'll write down the conclusion here. Hence, the Fourier transform of an unit impulse function is unity. Okay, it is unity. It is unity. And how do we plot it? We plot it like this. This is the plot of the Fourier transform of the impulse function. Is it fine? बुशरा, रोल नंबर 14, आपको बेटा ये समझ में आया?
जी सर.
Okay, what about 15?
Yes sir.
What about 46? कोई सवाल तो नहीं है?
नो सर.
Okay, is it fine? ठीक है ये?
यस सर.
चलिए ठीक है. देखिए, there is another question now. There can be a question like this. Find the inverse Fourier transform. That was the Fourier transform. ठीक है, वो Fourier transform था. There can be a question. Find the inverse Fourier transform. Find the inverse Fourier transform of delta omega. Okay, delta omega. So delta omega is the function now. and we have to find its inverse Fourier transform. Please note that if we have to find the Fourier transform of x of t, we write this is how it is written. F of x of t means Fourier transform of Fourier transform of x of t. But if we write down f inverse of x of t, it means inverse Fourier transform of x of t. Okay, it is not actually x of t, it will be x of omega, because inverse Fourier transform means it is already in frequency domain. It is already in frequency domain, so uh, it should be f inverse of x of omega. So इनवर्स फोरियर ट्रांसफॉर्म उस चीज का निकाला जाएगा जो ऑलरेडी फ्रीक्वेंसी डोमेन में होगा. ठीक है. Now please remember, I have already told you in my previous lectures that inverse Fourier transform is calculated by this equation: 1 by 2 pi integral of minus infinity, limit of integral is minus infinity to plus infinity, then x of j omega. What is x of j omega? It is Fourier transform of a signal. Okay, जैसे यहाँ पे हमने कहा था x of j omega. X of j omega is nothing but Fourier transform. तो inverse Fourier transform का ही निकाला जाएगा. Then it is e raised power j omega t, then d omega. This is the general formula or general equation by which we can find out the inverse Fourier transform. So inverse Fourier transform in our case will be inverse Fourier transform will be equal to x of j omega. Inverse Fourier transform of x of j omega will be equal to 1 by 2 pi in our case. Okay. What is x of j omega? X of j omega here in our question, it is delta of omega. It is delta of omega. Okay. In our question, it is delta of omega because we have to find inverse Fourier transform of delta omega. So it is delta omega. So it will be equal to 1 by 2 pi integration from minus infinity to plus infinity. Then x of j omega ki bajaye we have to write down delta of omega. Then e raised to power j omega t, then d omega. This is the inverse Fourier transform equation. Okay. So Fourier inverse Fourier transform of delta of omega can be then written as 1 by 2 pi. 1 by 2 pi. Okay. 1 by 2 pi. Then delta of omega. Now see, at omega equal to 0, this is an impulse function. Delta, it is a delta unit impulse function. At omega is equal to 0, it will be unity. It will be unity. So we can write down, if we substitute at omega equal to 0, then it will be unity. So I am not integrating it. Please note it. I am substituting the value of delta of omega. Delta of omega is equal to unity. Okay. At omega is equal to 0. And if we take the convolution integral in that form, then we can write down this equation as it is equal to this entire form. It will be equal to x of omega. X of omega at omega is equal to 0 means x of 0. जैसे यहाँ पे मैंने लिखा है, like I mentioned it here. So this is in this form now. Okay, x of t, delta of t. अब वहाँ delta of omega है. तो instead of x of t, what I have there, see, instead of x of t, I have here e raised to power j omega t. Okay, e raised to power j omega t. Okay, just a second. So you have two parts. This is x of omega and this is delta of omega. Together, it resembles this integral minus infinity to plus infinity delta of omega x of omega d omega. अब ये यहाँ पे जो जो इंटीग्रल है वेरिएबल इज ओमेगा. इट कैन बी टी आल्सो. वी कैन it also resembles like this delta of t x of t dt. Okay, in that sense, the value of this will be equal to x of 0 if we are assuming that the impulse is present at t equal to 0. So that's what I am saying here, that the value here will be equal to 1 by 2 pi into e raised power j omega t if we assume that the impulse is present at omega equal to 0. Okay, if we assume that impulse is present at omega equal to 0. Further, we can write down this. So this is an explanation. Okay, this is something else. Further, we can write down then inverse Fourier transform of this function will be equal to 1 by 2 pi, 1 by 2 pi at omega equal to 0. Then you have e raised power j into 0 into t. Then you will have e raised power 0, e raised power 0. Okay, e raised power 0. So that will be equal to 1. So you have 1 by 2 pi into 1 here. Okay, which is further equal to 1 by 2 pi. 1 by 2 pi. So we can write down inverse Fourier transform of delta of omega. It is equal to 1 by 2 pi. Okay, inverse Fourier transform of delta of omega, it is equal to 1 by 2 pi. Or we can also write this on this side. It is f inverse. F inverse is inverse Fourier transform. That also means if we take Fourier transform of 1 by 2 pi, Fourier transform of 1 by 2 pi, we'll have delta of omega. And limit
सर नॉइज आ रहा है और वॉइस बहुत कम आ रही है.
सबको ऐसा ही हो रहा है?
Yes, sir.
Everybody is facing the same problem?
Yes, sir.
Okay.
सर
Let me rejoin. Is it fine now? Voice
sir.
थोड़ी क्लियर आ रही है?
Yes, sir.
Okay, ठीक है. So what I was saying that I have taken a Fourier transform of this equation. Say for example, this is equation 2. Okay. So what I have done, I have taken Fourier transform of this equation. So this equation will then become like this. F of Fourier inverse of delta of omega will be equal to Fourier transform of 1 by 2 pi. Okay. So Fourier transform and inverse Fourier transform, they will nullify each other. So what I'm saying now is, if we take Fourier transform of uh, if we take Fourier transform of 1 by 2 pi, we will obtain delta of omega. Okay, we will obtain delta of omega. So Fourier transform of 1 by 2 pi will always give us delta of omega. Delta of omega. Okay. Or we can say that uh, 1 by 2 pi 1 by 2 pi and delta of omega, they are duals to each other. Okay. They are duals to each other. Or I can write down if there is 1 by 2 pi here, if I take 2 pi on the right hand side, it will be 2 pi into delta of omega, then it will yield to 1. Okay, it will yield to 1. What does that mean? That means if you have one in time domain. If you have one in time domain, okay, like this, अगर आपके पास one है in time domain, so you have a signal which is x of t basically in time domain, and that is equal to 1. So that is equal to 1. If you take Fourier transform of this one, अगर हम one का Fourier transform निकालेंगे, then what it will give me, it will obtain this thing. We'll obtain a Fourier transform graph of this form. This is omega now, okay? So this is x of j omega. So what is the Fourier transform that I will obtain? Just a second. तो ओके, जब हम वन का फोरियर ट्रांसफॉर्म निकालेंगे, then what I will obtain 2 pi into delta omega. So that will be a delta function, okay, delta function or impulse function, but its amplitude or its height will be equal to 2 pi. So this is 2 pi delta of omega, okay. And if I take Fourier inverse of 2 pi delta omega, if I take Fourier inverse of 2 pi delta omega, so this is if I take Fourier transform, कि अगर इसका फोरियर ट्रांसफॉर्म निकालेंगे तो ये मिलेगा, लेकिन अगर हम इनवर्स फोरियर ट्रांसफॉर्म निकालेंगे, इनवर्स फोरियर ट्रांसफॉर्म, then I will obtain 1. I will obtain 1. That is what I mean to say by this equation. Okay. Inverse Fourier transform and Fourier transform pair. 1 and 2 pi delta omega, they are Fourier transform pair. Fourier transform pair. That means if you take Fourier transform of 1, I will obtain 2 pi delta omega. But if we'll take inverse Fourier transform of 2 pi delta omega, we will obtain 1. Okay. Please note here from equation 2, inverse Fourier transform of delta omega only, it is equal to 1 by 2 pi. 1 by 2 pi. क्योंकि 2 pi into delta omega, inverse Fourier transform of 2 pi delta omega is equal to 1. So only if you take only Fourier inverse of delta omega, it will be 1 by 2 pi. I'll ask students if you have any question. Otherwise, I'll proceed ahead. किसी को कोई सवाल तो नहीं है? मुर्तजा 26. मुर्तजा.
सर जो आपने अभी एंड में बोला ना कि आप वो रिपीट कर सकते हैं।
हाँ मैं वो करूँगा, कोई बात नहीं।
इक्वेशन 2 का।
नो प्रॉब्लम, I'll repeat that. किसी और को कोई सवाल तो नहीं है? मुर्तजा को कोई सवाल तो नहीं है?
सर
ये किसने कहा रिपीट करने को? क्या नाम है बेटा आपका?
सर 70 अरबा।
ओके, नो प्रॉब्लम। रिजवान को समझ में आया?
यस सर।
ओके, सवाल तो नहीं है कोई बेटा?
नो सर।
बुरहान इज हियर 33.
यस सर।
आपको बेटा समझ में आया?
जी सर।
ओके, जस्ट अ सेकंड. Okay. Now see, what I was saying that मैंने कहा, first of all, I said that Fourier transform of 1, Fourier transform of 1 is 2 pi delta omega, 2 pi delta omega. Okay, that is shown in equation 3. So I said Fourier transform of 1 will be 2 pi delta omega. And I also said if we take inverse Fourier transform of 2 pi delta omega, inverse Fourier transform of 2 pi delta omega, then what I will obtain? I will obtain 1. Please remember, Fourier transform of 1 is equal to 2 pi delta omega, but inverse Fourier transform of 2 pi delta omega, it is equal to 1. So it is, a two-way traffic, just like that. अगर आप किसी नंबर का फोरियर ट्रांसफॉर्म निकालोगे, इफ यू टेक फोरियर ट्रांसफॉर्म ऑफ x, इट विल गिव यू y. अगर आप y का इनवर्स फोरियर ट्रांसफॉर्म निकालोगे तो इट विल गिव यू x बैक. ओके, दैट इज, इट इज अ टू वे ट्रैफिक, बाई डायरेक्शनल प्रोसेस. तो इसी चीज को मैंने प्लॉट किया यहाँ with the help of graphs. I said that if we have one means a DC value, by the way. Okay, one would mean a DC signal. One would mean a DC signal. So you have a continuous DC signal, and its amplitude is equal to 1. Its amplitude is equal to 1. Its magnitude is equal to 1. Okay, so if you take Fourier transform of that, you will have 2 pi delta omega. 2 pi delta omega. And obviously that is true because in DC you do not have any frequency component. So the frequency component is 0. Omega is 0 here. Omega is 0. You do not have any frequency component. But if you take inverse Fourier transform of 2 pi delta omega, उसको मैंने graphically कहा कि वो बराबर हमें वही DC value देगा. ठीक है. अब देखिए इक्वेशन 2 को मैं यहाँ पे दोबारा लिखता हूँ. आई विल राइट डाउन इक्वेशन 2 हियर. आई सेड फोरियर इनवर्स ऑफ डेल्टा ऑफ ओमेगा, इट इज इक्वल टू 1 by 2 pi. ओके, 1 by 2 pi. सो बेसिकली था ऐसा, फोरियर इनवर्स ऑफ 2 pi डेल्टा ओमेगा, इट वाज इक्वल टू 1. अब क्योंकि ऊपर जो 2 pi ऊपर जो डेल्टा ओमेगा है वो यहाँ है, तो 2 पाई तो नहीं है. फोरियर इनवर्स अगर आप इक्वेशन 2 में दिखोगे, इनवर्स फोरियर ट्रांसफॉर्म ऑफ डेल्टा ओमेगा है, सो यू डोंट हैव 2 पाई देयर, सो दैट 2 पाई विल कम हियर. सो इट विल बी, instead of 1 it will be 1 by 2 pi. Okay, so if that is what you have here, 1 by 2 pi. वही मैंने कहा कि वो 2 पाई इसीलिए है. जब हम इनवर्स फोरियर ट्रांसफॉर्म डेल्टा ओमेगा का निकालते हैं, it will be 1 by 2 pi. Why? Because basically Fourier inverse of inverse Fourier transform of 2 pi delta omega is equal to 1. अब वहाँ 2 pi तो नहीं है, तो वो यहाँ राइट साइड में आ जाएगा. That is what I was trying to say. It is very simple thing. So this was one thing that we have to remember. Equation 3. ठीक है, Fourier transform of 1 is always equal to 2 pi delta omega. It's a very important equation that may be used in future somewhere. Okay? To derive important conclusions. All right. Now see, there could be now another question now. Find the inverse Fourier transform. Find the inverse Fourier transform. Find the inverse Fourier transform of a signal, okay, of a signal which is equal to delta of omega minus omega naught. So this is now a shifted pulse. It is a shifted pulse. Okay, it is a shifted pulse. And we know general equation of inverse Fourier transform. Shadab is here. Shadab? Shadab? Roll number 48. Can you hear me? 46.
Yes, sir.
What is inverse Fourier transform general equation equal to?
F inverse अगर जनरली बात करें, F inverse x of j omega is equal to 1 by 2 pi integration
Yes.
of minus infinity by infinity x of
It is
j omega.
It is equal to 1 by 2 pi integration of minus infinity to plus infinity, then x of j omega,
J
then
omega is power j omega t.
e raised power j omega t, then
dw.
dw or d omega?
D omega, sir.
D omega. There is no w.
Yes, sir.
Okay, there is no w. Please note that it is omega. D omega. D omega. Okay, so that is the correct equation now. So in general, so this is inverse Fourier transform. Okay, so in our case, inverse Fourier transform of delta of omega minus omega naught, because this is our equation, this is our signal now, okay, in frequency domain. That will be equal to 1 by 2 pi. I'll ask students, they'll help me in writing it. Maybe Ikra, roll number 21, will tell me what is the next thing I should write down. Roll number 21. 21.
Yes, sir.
What is the next thing I should write down? अपना क्या ये बंद खुला रखो माइक और बात करो.
Yes, sir.
जी बताइए, what is the next thing I should write down? Nihal Bhatt, roll number 4. Roll number 4.
Yes, sir.
What is the next thing I should write down? Please turn on your camera, Nihal. अपना कैमरा ऑन करो.
I'm on PC. I don't have webcam.
You are on PC?
Yes, sir.
How do you connect it to internet?
So I have internet.
उसमें कैसे कनेक्टिविटी है?
LAN.
LAN के थ्रू?
Yes, sir.
Are you sure? What is the next thing I should write down here?
Sir.
Riyanul Qadir. Riyan, roll number 36.
Yes, sir.
What is the next thing I should write down?
Integration of minus infinity to plus
minus
infinity.
Very good. Okay, integration of minus infinity to plus infinity. Then delta of
Omega minus omega naught.
omega minus omega naught, because x of j omega is my this is actually x of j omega. Okay, so it is x of j omega is delta omega minus omega naught. Then I have e raised power j omega t. Then I have d omega. Okay, d omega. Now you know, using the shifting property, using shifting property of impulse function. What is the shifting property? We know that if we have an integral minus infinity to plus infinity, then you have x of t into delta of t naught, okay, or delta t. Let us not write down delta t naught. Delta t dt, it is equal to x of t naught. It is equal to x of t naught at t equal to t naught. If we assume that impulse is present at t naught, okay, so delta of t, it is equal to delta of t naught basically, because it is present at t naught. Anyway, this should have been like this.
Sir, I think it's delta of t minus
t minus t naught. Yes, it is delta of t minus t naught. Delta of t minus t naught. Okay, delta of t minus t naught. So using this shifting property that we have discussed long before, I can write down then equation, if I'll call it equation 1 now. I can write down equation 1 now, Fourier inverse of delta of omega minus omega naught. It will be equal to 1 by 2 pi. 1 by 2 pi. Okay, I'll ask students what should I write down the next thing. Maybe Murtaza 26 will tell me. Murtaza, can you hear me?
Yes, sir.
What should I write down now, beta? It is equal to 1 by 2 pi instead of this entire thing. Okay, integration
minus infinity to plus
infinity
delta.
Asim Khan, roll number 40.
Yes, sir.
What should I write down, beta, next?
Sir,
What should I write down? I have to write down x of t0. X of
sir,
t0.
x of t0.
T0. So please decode the x of t0 here from the equation above. Equation 1 से x of t0 निकालो.
सर x of t0 आएगा ना बराबर डेल्टा ओमेगा माइनस ओमेगा नॉट के बराबर और x of t0 इंटू e j ओमेगा नॉट
e j x of t0 किसके बराबर होगा? e j
ओमेगा नॉट
ओमेगा नॉट
सर ओमेगा t
omega t.
d ओमेगा.
So this will be equal to at omega equal to omega naught. That is what it will be. ठीक है, ये यही होगा. So we can further write it down 1 by 2 pi into e raised to power j. Omega को बनेगा omega naught. Then you have t. Okay. Omega को बनेगा omega naught. Then you have t. So please remember now Fourier inverse, inverse Fourier transform of delta of omega minus omega naught, it is always equal to 1 by 2 pi e raised to power j omega naught t. That is the first thing. Okay. If we take Fourier on the both sides, Fourier transform of this equation, say for example, this is equation 2. If we take Fourier transform on both sides, okay. So on the left hand side, you have already inverse Fourier transform. Then you take Fourier transform, it will be, that will be, the operation will be cancelled. So you can write down then delta of omega minus omega naught will be equal to Fourier transform of 1 by 2 pi e raised to power j omega naught t. Okay, it is the same thing that I have done here in the previous question. वैसे ही मैंने इसमें भी किया. Okay, so this is what I can conclude now. And in fact, I can also conclude this. I can say that if we take Fourier transform of 1 by 2 pi e raised to power j omega naught t, then what I will obtain? I will obtain delta of omega minus omega naught. Okay. Or if I take, this is C, this is what I'm saying, I'll take Fourier transform of 1 by 2 pi e raised to power j omega t, then I will obtain this thing. But if I will take inverse Fourier transform of delta of omega minus omega naught, then I will obtain this quantity. Okay. Similarly, I can also write down, if I take Fourier transform of only e raised to power j omega naught t, only e raised to power j omega naught t, if I take Fourier transform of only e raised to power j omega naught t, then 2 pi will come on right hand side. So we will have 2 pi delta of omega minus omega naught. Okay. So I am taking Fourier transform of e raised to power j omega naught t. And similarly, if I take inverse Fourier transform of 2 pi delta omega minus omega naught, then I will obtain this quantity. Okay. So we should remember then e raised to power j omega naught Fourier transform will be equal to 2 pi delta omega minus omega naught. So these are duals in terms of Fourier and inverse Fourier transform duals. Okay, they are Fourier transform pairs, we can say. Pairs would mean if you take Fourier transform of it, it will give you y. If you take the inverse Fourier transform of y, then it will give back to you the original result. Okay. Similarly, I can write down, please note it down. Similarly, I can write down, see, this was a positive here. Okay. It was a positive here. Omega naught here is positive. Okay. Omega naught here is positive. It is positive. If omega naught is negative, अगर omega naught negative हो गया, तब मेरे पास क्या होगा? Then I will have e raised to power minus j omega naught t. And if I will take a Fourier transform of it, it will give me 2 pi delta of omega. So you had minus omega naught. So instead of minus, you will have plus now, plus omega naught. Okay. So that is also another pair. So this is one pair and this is another pair. Please try to compare these two terms. पहले में ओमेगा है पॉजिटिव, दूसरे में ओमेगा है नेगेटिव. So what is the difference then? The only difference is in the result, that instead of positive negative sign, you will have a positive sign. You will have a positive sign. Is it fine? I'll ask students. कोई सवाल तो नहीं है यहाँ तक? उज़मा को कोई सवाल तो नहीं है? उज़मा बेटा आपको समझ में आया?
जी सर।
रोल नंबर 70 आपको समझ में आया?
Yes, sir. Yes, sir.
Okay. What about रिजवान? रिजवान को समझ में आया?
जी सर
54 आपको समझ में आया?
Yes.
24
Yes, sir.
ओके ठीक है. अब देखिए जो हम ये बात कर रहे हैं इसके बिना भी विल ड्रॉ अनदर कंक्लूजन नाउ, एंड दिस इज वेरी इंपॉर्टेंट. ओके, इट इज वेरी इंपॉर्टेंट कंक्लूजन. यू विल रिमेंबर दीज वर्ड्स वंस यू स्टडी कम्युनिकेशन सिस्टम्स. आपको वहाँ ये चीज़ें ज़रूर पढ़नी पड़ेगी. तो वहाँ इतनी वजाहत तो नहीं होगी. Teacher would not explain it in this fashion, but I have given you the sufficient explanation for that. Now I have a very common question, okay, that you will be dealing many times in your engineering. Find the Fourier transform. Find the Fourier transform of the everlasting sinusoid cos theta, cos of omega naught t. Please remember that in our communication, we transmit our messages using some carrier waves. Okay, using some carrier waves. Our information is superimposed on carrier waves. Those carrier waves, they carry our information to longer distances. Generally, all those carrier waves are sinusoid. Whether cosine or sine waves, they are sinusoids. Okay, so we have to find out the Fourier transform of a sinusoid. That is the cos theta, cos omega naught t in general. Okay. Now see, if we solve this, if we try to find out the Fourier transform, we know from Euler's formula, we know from Euler's identity, we know from Euler's identity, e raised power j theta, e raised power j theta. What is e raised power j theta equal to, Abrar? It is cos theta, Abrar? Okay, e raised power j theta, it is equal to cos theta plus j sine theta. Okay, e raised power j theta is equal to cos theta plus j sine theta. And e raised power minus j theta, e raised power minus j theta, it is probably equal to cos of theta minus j sine theta. Okay, minus j sine theta. And I have told you yesterday we derived them. If we add and subtract them appropriately, we can find cos theta. Cos theta will be equal to e raised power j theta plus e raised power minus j theta divided by 2. Okay. Similarly, if we subtract them, we can find out sine theta. Sine theta will be e raised power j theta minus e raised power minus j theta divided by Shomia, what is in the denominator? Roll number 60.
Yes, sir.
60. What is in the denominator? Divide by 2. 2t.
Yes, sir. Divide by 2.
Only 2?
2j,
So
2j,
divide
sir.
2j. Okay, divide by 2j. ठीक है. Okay, मैं भूल गया था. So it is divided by 2j. Okay, ठीक है. So that's it. Now see, we know that our signal is x of t. Our signal is x of t equal to cos of omega naught t. Omega naught t. This is our signal. So how can we write down cos x of t, yeah, cos of omega naught t in terms of exponential terms? We can write it down as one. It will be e raised power j theta. Theta is omega naught t. Okay, e raised power j omega naught t. Then you have plus e raised power minus j theta. That would be e raised power minus j omega naught t. Okay, e raised power minus j omega naught t. What is left behind? रिजवान क्या है होगा इसके और क्या ऐड करना है इसको?
Divided by 2.
Divided by 2. Very good. Divided by 2. Okay. So I can write it down like 1/2 of e raised power j theta is j omega naught t plus minus j theta would be minus j omega naught t. So that is one and the same thing. Okay. One and the same thing. Okay. Now see, we know that what is okay. What is the Fourier transform of e raised power Fourier transform? We know that Fourier transform of e raised power j omega naught t. अगर मैं e raised power j omega naught t का Fourier transform निकालूंगा, we know what is e raised power Fourier transform of e raised power j omega naught t. We have already seen it here. Okay, it is equal to 2 pi delta of omega minus omega naught. Okay, e raised power j omega naught t को जब Fourier transform निकालेंगे, it is equal to 2 pi into डेल्टा ऑफ ओमेगा माइनस ओमेगा नॉट. ठीक है, इसी तरीके से ई रेज्ड पावर माइनस जे ओमेगा नॉट टी को अगर हम निकालेंगे, देन इट विल बी 2 पाई डेल्टा ऑफ ओमेगा प्लस ओमेगा नॉट. ओके, सो यू हैव माइनस हियर. सिमिलरली e raised power minus j omega naught t, if we take a Fourier transform of this, it will be 2 pi delta of omega plus omega naught. That is the only difference here. Okay, now since from equation 1, okay, cos of omega naught t here is equal to this thing. So what will be the Fourier transform of cos of omega naught t then equal to? It will be equal to Fourier transform of 1/2 of e raised power j omega naught t, okay, plus 1/2 of e raised power minus j omega naught t. Okay, तो ये यही होगा, because if you see from equation 1, cos of omega naught t is equal to 1/2 of something exponential terms. So I will ask students, Fourier transform of cos of omega naught t, what is it equal to? Okay, what is it equal to? So maybe I'll get a help from Mehvish 65. Mehvish beta,
Yes, sir.
what should I write down?
So we had a 2 pi, 1
हाँ,
by 2 pi,
okay,
the
2 pi.
delta omega.
ठीक है, ओमेगा माइनस ओमेगा नॉट पहले टर्म आएगी, फिर दूसरी टर्म आ जाएगी 2 पाई डेल्टा ऑफ ओमेगा प्लस ओमेगा नॉट, तो ये दूसरी टर्म आ जाएगी. ठीक है, तो जब आप इसको फाइनली देखोगे, इट विल बी समथिंग लाइक दिस. इसमें 1/2 है और वहाँ है, तो इट विल बी समथिंग लाइक दिस, पाई टाइम्स डेल्टा ऑफ ओमेगा माइनस ओमेगा नॉट प्लस पाई टाइम्स डेल्टा ऑफ ओमेगा प्लस ओमेगा नॉट. ओके, तो कुछ ऐसी आ जाएगी, यानी फोरियर ऑफ कॉस ऑफ ओमेगा नॉट टी का जो है फोरियर ट्रांसफॉर्म वो ये होगा. ठीक है, तो दैट्स इट. इफ आई विल प्लॉट इट, अगर इसको हम प्लॉट करेंगे, हमारे पास एक्स ऑफ टी था. व्हाट इज एक्स ऑफ टी? एक्स ऑफ टी वाज लाइक दिस. सो दिस वाज माय एक्स ऑफ टी. ओके, ये है टाइम डोमेन में. And what was my x of t? X of t was equal to cos of omega naught t. Okay, so it was equal to something like this. It is a cos signal. Okay, cosine signal, and that was everlasting. Everlasting means unending. यहाँ से भी है और वहां से भी है. So it was a cosine signal. So if I take a Fourier transform of this, if I'll take Fourier transform of this, what is the Fourier transform? Now see, Fourier transform will be like this. This is omega, and this is x of j omega, x of j omega. Or what is my Fourier transform? So I have two components here. ठीक है, एक स्पाइक होगा इक्वल टू ओमेगा नॉट, दूसरा होगा स्पाइक इक्वल टू माइनस ओमेगा नॉट. शिफ्टेड पल्सेस होंगी दो, तो एक यहाँ होगा ओमेगा नॉट पे, दूसरा यहाँ होगा इक्विडिस्टेंट पे माइनस ओमेगा नॉट पे. ठीक है, and what will be the height of these pulses? It will be equal to pi. Okay, the height will be equal to pi times delta omega minus omega naught. So this is pi times delta of omega minus omega naught, and this term is pi times delta of omega plus omega naught. ठीक है, ये दो terms आई in the frequency domain. So that was the plot of this signal. If you have any question, you can ask me. Otherwise, I'll stop now. कोई सवाल है तो आप पूछ सकते हैं. किसी बच्चे कोई सवाल है?